Hello, my name is Daniel Pastuhov and welcome to the Java programming course. Let's see first what this course will cover. First of all, we will see some concepts of the Java and then how to store data in variables and types and how to read data from the user and how to print data to the user and then how to do simple calculations. The programs are just like reading books. So you read from top to down, from left to right. And if this is not okay for your program, then you can make conditions that controls which part will be running and which part will not be running. And if you want to repeat a part, then you can use loops. And we will see how to use some tips and tricks in the NetBeans, how to debug the program and what debug means, how to use the code templates, which are abbreviations of the statements that we will use. We will reveal the secrets of basic algorithms, so how to sum up elements in the series, how to count elements that are appropriate to a condition, how to determine minimum and maximum of the series, and how to search inside. And then the arrays. They are multiple elements together, and we will see how we can use one-dimensional and how we can use two-dimensional arrays. They are just like the spreadsheets. And then the functions and structured programming functions are very similar to the genies. We can assign tasks to genies and then invoke, and they will do what we want them to do. And based on the genies, with a herd of genies, we can create a whole program, and they are very useful for constructing the program and structuring the program. Since the Java is an object-oriented programming language, we will see what classes, objects are, and how to use the inheritance for creating new classes out of the original ones, and what the polymorphism is. We will see how to handle dates and times. There are two methods, one old and one new. The new one introduced in the Java 8, so we will see both of them. And then how to sort elements and why it is useful and what the benefits of the sorting are. There is an interesting part of the Java. This is the generics, and we will see what the secrets of the type parameters are. We will see what the collections framework is. They are classes that are useful for storing objects in different ways. We will see what the list, the set, and the map are. And then if something goes wrong, then the Java will create and throw exceptions, and we have to catch it and return back to normal state. How to do this and what this is. In the background of the file handling, there are the streams, what the streams are, how to use them, and what the properties are. Properties are for using the ini files. And if a variable can contain only a specific set of values, then we can use enums. An example is the days, Monday, Tuesday, Wednesday. So if we have only these values, then it is worth using enums for that. And last but not least, when we would like to do something, maybe someone else has created a solution for it. We don't have to reinvent the wheel, so we will see how to use other people's work in our programs. During the course, we will write a lot of exercises because programming is just like martial arts. You cannot learn it from books, you can learn it by exercises. So we will have smaller exercises that demonstrate the different aspects of the programming language, and we will write a simple computer game, which is a role-playing game in which you are the hero. The idea is based on the Fighting Fantasy. The Fighting Fantasy game books are created by Steve Jackson and Ian Livingstone, and while the normal books are read from the chapter 1 to the last chapter, in the Fighting Fantasy books you can decide in each chapter where to go, what to do. An important thing in these game books are the dice. We will use dice to create the different attributes of the character, and we are using dice to fight with the monsters. Just like any other fantasy worlds, The world of the fighting fantasy is very colorful. It contains a lot of different monsters. In our program, we will simulate the fighting with these monsters until death. Let's review what we will do in this video. First of all, some basic concepts about the Java, and then we will install our working and learning environment, the NetBeans, and then we will write the Hello World project. This is the very first program you write when you start learning a programming language. And then I introduce the variables and types, which is a concept for storing data. And then we learn how to read in and write data for the user and how to do simple calculations. We will learn the conditions, and based on these conditions, one part of the program will run and the other part of the program will not run. And last but not least, we start the You Are the Hero program. We will write the first part of it. As you might know, the Java is a very popular programming language. If you read statistics on the internet, all agree that the Java is in the top 3 most popular programming language, and some of them say that Java is the most popular programming language. And you might hear the expression, 3 billion devices run Java. And Java is a platform-independent programming language. That means you can write your code once and you can run it anywhere. And there are a lot of well-paying jobs. This might be very interesting for you because there is a great demand for Java developers and you can have a very good and well-paying job if you learn Java. And it's widely usable. If we consider the Java platform as a tree, the tree is based on the basic computer skills. That is folders, operating systems, running programs. On the basic computer skills, there is the programming in Java. After learning programming Java, you can learn basic Java tools. And after that, you have 3 options. You can be a mobile application developer. You can be a desktop application developer, or you might go to a huge company and develop enterprise applications. Inside the mobile applications, a very big part is the Android. 60% of the market is the Android. There is another technology, Java ME. It was quite popular before the Android, but now it's less important nowadays. The second option is the desktop application development. You can develop games. You might know the Minecraft. It's a quite popular game nowadays and it is completely written in Java. Or you can develop software tools. For example, NetBeans and Eclipse are written in Java. We will use NetBeans to learn Java programming. And if you are a researcher, it might be interesting for you that there are a lot of applications that are developed by the Java in the research field. The third option is that you go to a huge company as a developer, and it might be interesting that 90% of the Fortune 500 companies use Java. If you go to a huge company, you might develop e-commerce applications or banking applications or huge backend services. In this course, we will cover the first 2 topics, the programming in Java and basic Java tools. As I said, the Java is a platform-independent programming language. What does it mean? Let's suppose that you, as an English speaker person, you travel to Europe. And as you might know, Europe is a multicultural continent. There are a lot of languages. So let's suppose that if you look at a pretty girl, you want to tell her that she is a pretty girl, she won't understand you. So what can you do in this situation? You can translate your message with a device. You use your mobile phone and you use your translator on your mobile phone. So you type in what you want to tell the girl and it translates to, in this case, Italian. And the girl understands you. This is the compilation. when your message will be transformed to another version that is understandable for the other party. In the computer field, you are the user who wants to do something, and the computer won't understand you unless you translate your message to the computer. This is the compiling. What other options exist in this case? The other option is to interpret the message. The situation is the same, and you hire someone who speaks English and Italian. So you tell her your message, and she interprets your message. And the girl will understand. So, as you might see, this is a slower method of communicating with someone. In the computer field, if you would like to tell the computer something, then you can use another program that translates your message on the fly. And this is the interpretation. Okay, let's see the Java style. Java is a platform-independent programming language. What does this mean? Let's consider the situation. You are traveling through Europe and you want to talk to every single pretty girl you introduced. So her and her. In this case, you might use your mobile phone to compile your message to a common language. In this case, we will use the Esperanto language, which was intended to be used as a common language throughout the world without any success. So in this case, we compile our message to Esperanto and we hire some other persons who will understand this Esperanto and the native languages. And we show the interpreters this message and she will translate the message for the pretty girl. And the pretty girls will understand the message. So in this case, in the Java terminology, the output of the translator, the output of your mobile phone, is called the bytecode. And the interpreters that interpret your message, your translated message, are called virtual machines. If you start dealing with the Java programming, you might hear a lot of abbreviations, expressions, just like GRE, IDE, JDK, JVM, NetBeans, and Eclipse. What are they? And what do you need for starting programming? In the core of the Java is the Java virtual machine. In our analogy, that was the girl who was hired to translate our compiled message from Esperanto to the native language. This Java virtual machine is the part of the Java runtime environment, the JRE. This software is needed for you if you would like to show your program to your mom, to your spouse, or to your kid. You have to install this software to their computers. If you want to make Java programs, you need the Java Development Kit. In our analogy, this was the mobile phone with the translator. The Java Development Kit contains the Java runtime environment. This you have to install to your computer. But using this part is not so comfortable. It's more comfortable if you use integrated development environments. For example, NetBeans and Eclipse. They are very popular. And because the NetBeans is easier to use for beginners, in this course we will use the NetBeans. Okay, let's see how to install the NetBeans and the JDK. First, start a browser and in a Google search, let's search for JDK NetBeans 8. 8 is the version. And the first one is the NetBeans plus JDK bundle. This is what we will need. And in the download page, first accept the license agreement, and then these links will be clickable. There are different operating systems and different bit numbers. x86 is the 32-bit version and x64 is the 64-bit version. Which one do you need? I suppose that you know which operating system you are using. I use currently Windows. So the question for me is which version I should download and install. How to figure out. Let's right click on the computer, and in the properties, you will see the system type 32-bit operating system. That means for me, only the 32-bit version will be appropriate. If you see here 64-bit operating system, you might choose whichever you want. But I suggest the 64 version. So I download the bundle. Okay, so when the download is finished, let's click on the installation kit. And let's start it. And then the installation kit will configure itself. And the program will start. The installation procedure is a simple one. I suggest you to install the JUnit system. It will be usable for class testing. And it will ask us which directory we should install the JDK. This default is appropriate, so click on Next. And then it asks where to install the NetBeans IDE, and the JDK is configured. Next. And then after everything is set up, we can click on the install button. Okay, so after finishing the installation, the NetBeans installer asks us if we would like to contribute to the NetBeans projects by providing the anonymous usage data. You can leave it like this, or you can switch it off if you want to. I switch it off. So I think it is finished. So the NetBeans IDE is on the desktop. Let's start it. Okay, so after installing the NetBeans IDE, let's run the program. You will see a window very much like this. The start page is not necessary for us anymore, so click on this checkbox and switch it off and close it. And after that, we will have a window split into two parts. This left part will contain our projects. One project is simply a program. We can have a lot of programs next to each other. So we will create now a new program, that is, we create a new project. So click on the file, new project. And in the appearing dialog, select the Java and Java application and click on Next. And here, let's type the hello world, since we will write our very first application, an application that print out the hello world text. This is a very common first program in every environment. So make sure that this create new class will remain switch on, and then click on finish. Okay, as you can see here in the projects window, there will be a hello world application, and this will contain everything that is necessary for compiling our project. And the NetBeans will open up the source file. This will contain the code that we would like to run. In the source code, there are gray areas. These are comments. They are for us, not for the computer. They do simply nothing. They are just remarks for us to know what happened here. And there is a package declaration here. This package declaration shows which package this source code is in. A package is simply a container for our source code files. We might have hundreds or thousands class files, source files. So if we package up to smaller parts, then we might have a better view. And the NetBeans created as a class. Everything in Java will be contained in a class. And there is a main function. I will explain the class and the function later. We have to know that our program has to be written into the main function. So let's remove this comment here. And let's type in system.out.println. And in the quotation marks, let's write hello world. This is our very first program. And let's run it. Let's click on this green triangle. This will run our project. It will compile and save automatically when we click it. And after a while, a new sub-window will appear, and this will be the output of our very first program. So congratulations. So the very first concept we have to get to know is the concept of variables. Imagine a wardrobe. If you open up your wardrobe, you find your valuable things in the different places. The variables are very similar to these places. You can put your important things to these places. So simply a variable is a place to put your important thing. What is an important thing for a program? Is the data. And you can have different type of data. You can have a number, you can have a character, you can have a text, and you can put them into variables. But as you don't put your shirts into the place of t-shirts and vice versa, and you don't put your underwear in the place of t-shirts, you won't put your text into the place of numbers. And you don't put your numbers into the place of text. So in the case of variables, we define another concept. This is type. The type represents what kind of data you want to store. What kind of variables and types are there in Java? If we consider all the types, we can divide it into two parts. One is primitive type, very simple data, and the classes, which is a little bit more complex data. Let's examine the primitive types first. If you take the primitive types, there are the numbers. So all the numbers can be here, and there are characters and Boolean. So a character can mean a letter, a sign, a space, so everything which is one character. And the Boolean can contain true or false. Numbers are not one single type, but numbers are different. So there are integral numbers, just like 1, 2, 3, 1000, and so on. And there are real numbers, 1.2, 2.3, and so on. Among the integral types, there are many types. And one is smaller, can contain fewer numbers, and there are bigger types. So the smallest one is the byte. It can contain only tiny numbers. Short is bigger, int is bigger than the short, and the long is the biggest. And among the real types, there are two. The float is the smaller type, and the double is the bigger type. Most of the cases we will use the int and the double. Okay, let's make an exercise. It is called value replacing exercise. The exercise is about replacing the value of two variables. Let's take this simple code. Inside the main function, we create an int variable. The name will be first, and the type is int, and the value is 7. So we would like to store the 7 in the variable first, and the type is int. And we create a second variable. The name is second, the type is int, and the value is 19. And after some code, this is a comment, we will print out the result, system.out.println, and first will be a text, and then we will print out the value of the first. In this case, this is 7. And then we will print out the second and the value of second. So in the quotation mark, this will be printed character by character, and outside the quotation marks, this will be the name of the variable and the value will be printed out. Okay. And the exercise is about to replace the value of two variables without writing any more numbers and without changing the existing lines. Only write new parts here. But before solving this one, let's see how it works. Let's create a second project. The name will be replace. And make sure that the NetBeans will create the main class. Click on finish. So first of all, let's create a variable. The type is int. And the name will be first. And we can assign a value to the variable, in this case 7. So type, name, and value. And let's create a second variable. Type is int, name is second, and the value will be 19. Okay, what can we do with these variables? First task is to print out to the screen. So first we print out a string, first, and then we print out the value of the first outside the quotation mark, and then we begin a further quotation mark. This will be second equals, and then outside the quotation mark we will print out the value of the second variable and the semicolon at the end. Okay, let's see what it does. So let's start, and it will print out. As we can see, the thing inside the quotation mark will be printed out character by character, and then the other first, this black one, will be replaced by the value, and then the second character by character, and then the second will be substituted with the value of the second. Let's make another exercise. Let's consider two glasses, one with red wine and one with white wine. And the task is to replace the content. How to do that without mixing up the wines? The idea is to have a third glass. So you will pour the white wine to the third glass, and the second glass will be empty. So you can pour the red wine to the empty glass, the second one, and you can pour back the white wine to the first glass. And now the task is solved. How can we use this experience? Okay, so let's create a third variable, just like the third glass, and we put the content of the second into the third one. And then the second will be empty, and we put the content of the first to the second variable. And then the first is empty, so we can put the value of the third into the first. One remark for the emptiness of the variables. I consider them to be empty, just like the glasses, but in reality they won't become empty when you assign their values to another variable. After the assign, both variables will contain exactly the same value. Let's see how it works. and they are replaced. So congratulations. The next exercise will be the temperature exercise. We will write a program that reads in an integer value, which is a Celsius value, and we will calculate and print it in Fahrenheit grade. The formula is here in the bottom right corner. What we don't know to solve this problem. First, we don't know how to read in a number from the user, and the second one is how to make calculations. Okay, let's see how it works. Okay, so let's create the solution of the temperature exercise. So first of all, let's create a new project. Java category, Java project. Next, and let's create a temperature project. Make sure that it will create the main class. So first of all, we will print out something for the user that please give in the Celsius value and how to read in a number. For reading in a number, we have to create a tool. This is written by the Java developers, and this is called scanner. java.util.scanner. I will name it to SC, and we create a new Java util scanner. You don't have to understand this line. This is a magic line. We have to write this into the program if you want to read in a number. And just one remark here. You write here java.util twice. And we programmers are lazy, so we don't want to write things twice. So I would be happy if I could remove this java.util. But in this case, the Java compiler doesn't recognize the scanner. This is because the previous java.util was the name of the package the scanner is in. We have here hello world and temperature packages, and the scanner's package is the java.util. And we can reach tools from any other packages in the Java environment, but you have to specify the whole package name with the class name. But we are lazy, so we don't want to write that here. How to solve the problem, which appears here with an import line. This import line is a new line here, import java.util.scanner. And that means that every time I mention the scanner, it will understand that this is the java.util.scanner. Okay? So we created a scanner with this magic line, and this magic line will be used to read in a number. So first of all, we create a variable. This will be Celsius, and the value will be sc.nextDouble. That means we read in a double value and we put this double value into the Celsius variable. And after that, we have to calculate the Fahrenheit value by using our formula. So to store the result of the calculation, we create a Fahrenheit variable and we use the formula. 9 divided by 5 times Celsius plus 32. I will explain this 0.0 later. And after calculating the Fahrenheit, system.out.println, Fahrenheit is Fahrenheit. Okay, so let's run this program. It asks us the Celsius value. So for example, 20 degrees Celsius is 68 in Fahrenheit. So it works. So let's go back to this point O. If we write only 9, 9 is an integer and 9.0 is a double. So in this case, we are using always double values. Celsius is double, Fahrenheit is double. So we add double values into the formula. Okay, and one more remark. What if we are using integers here? Okay, let's see what happens if we are using integers. And we will give in the same value, Celsius 20. Okay, let's rerun the project. 20. So it's different. It was 68 and now it's 52. Why is there a difference between the two? The explanation for that is that the calculation is different when you use doubles or integers, especially the division. So if there is a division, then if you use doubles, then the result is double. So in this case, 1.8. And if you use ints, then it will be rounded down to 1. So if you calculate the result of this expression, then 20 will be multiplied by 1. This is 20, and plus 32 is 52. And in the other case, if you use double values, so 9.0 and 5.0, then the result of this sub-expression will be 1.8, and this will be multiplied by the Celsius value, which will be 36, and you add 32, so this will be 68. Okay, so always remember, if you use integers in the division, then the result will be rounded down. The next exercise will be in connection with the temperatures as well. In this program, we will read in a temperature value, again in Celsius, and we will print out if the water is boiling or not at the specified temperature. So what we don't know is how to run a part of the program based on the temperature value. Okay, so for solving the boiling exercise, we will create a new project like before. Boiling exercise. Okay, so first of all, we have to read in a number, which is a temperature value. So it's very similar to the previous exercise. So first of all, we print out something for the user, give in the temperature, and then we again create a scanner with this magic line, and we again import the scanner. So a new import line is appearing. And in this case, let's use integers. I abbreviate the temperature as temp, and we will read in an integer number. The scanner is a tool, and it provides us a lot of possibilities. Not only next double, but we have next int, next short, next byte, and we have functions for every types that I mentioned. So in this case, we will use the next int. And After reading in the temperature, we have to decide what to print out. If the temperature exceeds 100 degrees Celsius, then the water is boiling, and if it's below 100 Celsius, then it is not boiling. So the keyword for that is the if. And inside the if, we will write a condition. The condition is something that has a true or false value that can be decided if it's true or false. So in this case, if the temperature exceeds the 100, exceeds means equals or greater than 100, and this condition goes to parentheses, and after that, in curly brackets, the program statements, the program commands that will be executed when the condition is true. So in this case, this is very simple. We just print out that the water is boiling. Okay, and what should we print out when the water is not boiling? Because in this case, if you run the program, run the project. So in this case, if the temperature exceeds the 100 degrees Celsius, then this writes that the water is boiling. And what if not? Let's rerun the program and type in 88. And it prints out nothing. This is not always good. Sometimes it would be better if we print out something when the condition is not true. So in this case, we can use the else keyword and curly brackets. And inside the curly brackets of the else, you can write a statement to print out something else. The water is not boiling. So let's rerun the project. So when the temperature exceeds 100, then it prints out the water is boiling. And if I rerun the project and it doesn't exceed the 100, then it prints out the water is not boiling. Our next exercise will be the boiling and freezing exercise. This will be very similar to the previous exercise, but in this case we will have three options. Not only boiling and not boiling, but boiling, freezing, and normal state. What we don't know. Since we have more than two options, we have to join the ifs and create three options out of these two. Okay, so for the boiling and freezing exercise, we will copy the boiling exercise. So right click on the project, boiling, and select the copy. And here, provide the name boiling and freezing. This will be the name of the exercise, and click on copy. So a new project is created, boiling and freezing, with the same content. So we have two boiling.java, one in the boiling project and one in the boiling and freezing project. This is easy to mix up, so it's better if we rename the boiling.java. This can be done by right click on the name of the Java file and refactor and rename, or you can use the Ctrl+R. Rename, boiling and freezing, and click on refactor. So this will rename the file, and this will rename the class itself, but the content remains the same. Okay, so back to the exercise. It's very similar to the boiling exercise, but when the water is not boiling, so the water is boiling is done. But if the water is not boiling, then we have to divide it into two parts, when it is freezing and when it is in normal state. So instead of just printing water is not boiling, we will split up this option by an if. So if the temperature is below 0 or it equals to 0, then that means the water is freezing. The water is freezing. And the other option can be done by an else. And in this option, we are writing that the water is in normal state. Okay, so we have an if with an else, and in the else branch there is an other if else. So if we have a lot of branches, then this can be a very huge structure. So a little bit simplification. In those cases when the else contains only one instruction, then you can remove these curly brackets. And this if-else statement as a whole is one instruction. So let's remove these curly brackets, these yellows. And let's remove some tabs. So I will remove this tab, and this tab, this tab, this and this. So in this case, the logic is the same, but it's easier to read. So we have a branch with temperature exceeds 100. We have a branch which less than or equals to 0. And we have a branch that is everything else. Okay, let's try it out. So one branch is when the temperature exceeds 100, then the water is boiling. We didn't touch it, so it works the same. Let's rerun it. If it's below 0, then the water is freezing. And if it's in normal state, for example, 56, then the water is in normal state. What did we do in the boiling and freezing exercise with these ifs and else ifs and elses? Let's imagine a sausage. The sausage represents all the values from -infinity to +infinity. And with the first if, we cut one part of this area, just like if we cut the first part of the sausage. This was the first if. And in the else branch, we handle the rest of the sausage, the rest of the area. And in the else part, we cut it into two parts. The if of the else is the second part of the sausage, and the last else will be the rest of the sausage. And the sausage is eaten. Some might think in the boiling and freezing exercise that we have three separate branches, each with an if and without an else. So an if when the temperature exceeds 100, and another branch which is separated from the first if when the temperature is below 0 or equal to 0, and then a third branch which is executed when the temperature is between 0 and 100. But this expression is not understood by the Java, because this is not a complete condition. Complete condition is this one, and complete condition is this part. It simply doesn't understand. It understands if we write two separate but complete condition and join with something. In this case, we join with and. So if the temperature is greater than 0 and the temperature is below 100, then the water is in normal state. We saw in the exercise this AND operator, and this might be strange for you. This AND means that if we have two conditions, the resulting condition is true when both of the conditions are true. We have two more logic operators. One is OR. That means if one of the conditions is true or both of the conditions are true, then the resulting condition will be true. And we have the negate, which makes true out of the false and makes false out of the true. The next exercise is the fighting exercise, which is the first part of the You Are the Hero program. The goal of this exercise is to sum up everything we learned in this video. We will write a program in which you can fight with a monster. So in the program, first we read in the attributes of you and the monster, and then we will play one round of the fight. What will be the fighting rules? There will be some attributes for you and the monster. The attack points determines how strong you are in attacking the other party. Defense points, how good you are in defending yourself. The damage, how many damage you can cause to the other party. And the life points, how healthy you are. If it goes to 0, then you are dead. One round of the fight. First of all, we choose who will be the attacker. This is a simple coin toss. If heads, one of the party attacks the other. If tails, then the other party attacks. And then we roll 2 dice and add to the attacker's attack points, and we compare it with its enemy's defense points. If the attacker's result is bigger than the defender, then the attack is successful, and therefore the enemy's life points will be decreased by the damage. Otherwise, the attack is not successful. So what we don't know is how to generate random numbers. If we know how to generate random numbers, then we are ready to fight. Okay, let's create the solution of the fighting exercise. First of all, we create a Java project, Java and Java application, and then the name will be fighting. In the first part of the program, we will read in all the attributes of you and the monster. Because we are reading numbers, then we create a scanner. This is the tool for reading in numbers, and as always we import the scanner, and then we read in the attack points of the monster. The variable name will be monster attack, and we read in from the user. Then we read in the defense points, the first part of the monster. Monster defense will be the variable name. We read in from the user. Then the damage of the monster. This will be monster damage. And finally, the life points of the monster. Will be read from the user. And then your attributes. will be read in. After reading all of the attributes, we start the fighting round. The first thing that we have to decide is who will be the attacker. For this, we will do a coin toss. In the programs for that, we will use a random number generator, and this random number generator will generate us a number. In this case, if we would have to decide which party starts, we need not a number, but a Boolean value. So if true is generated, then one of the party will attack. If false is generated, then the other party attacks. So let's create the random number generator. This is the random number generator, and this is very similar to the scanner. This is a tool. We have to create it with new, and we have to import the java.util.random. And with this random number generator, we create a Boolean value. This Boolean value will determine which party will attack. We will use the next Boolean. We create the next Boolean value randomly. And after that, if the attacker is true, then that means that you will attack, and what you need is to roll 2 dice. Therefore, we generate another random value, in this case a random number. So generator the next int. If we write here a 6, that means this function will return a random value between 0 and 5 inclusively. 6 cannot be generated. So if we have this number from 0 to 5, then we add 1 to this 0 to 5 number, and then we get 1 to 6. This is a normal die. So I add 1 to the value. So this is 1 die, and we need 2 dice. So we generate another number from 0 to 5. And we add 1 more. So this is 2 dice. And according to rules, the attack value will be calculated by your attack points plus the 2 dice. But before we go on, let's print the values that was rolled. The rolled values and your attack value. And then we decide if your attack was successful or not. If the attack value is greater than the monster's defense, that means your attack was successful. And therefore you damage the monster. So the monster's life will be decreased by your damage. So we print out the remaining life of the monster. If the condition is not true, then your attack was not successful. Let's print it out. Unfortunately. Okay, so if you were the attacker, then this is your attack. Otherwise, the monster attacks. Let's print it out. Okay, and that's all. Let's run the program. And let's type in some values. The attack points of the monster will be 5, defense points 10, damage of the monster 3, life points of the monster will be 40, your attack points 10, your defense points 25, your damage 6, and your life points 40. And after that, you attacked. The rolled values was 6, so therefore your attack value was 16, which is greater than the defense points of the monster. Therefore the attack was successful, and therefore you damaged the monster, and the monster's remaining life points was 34. You successfully hit the monster, but it is still alive. To kill it, we still need to learn a lot. So let's see what's in the next video. One of them is to choose one from many. This is the switch statement. And for repeating things, just like fighting rounds, we learn the while, the do while, and the for loop. And we will learn 2 things to control the loops, break and continue. And finally, in the next video, we will learn how to put one loop in the other. And we will continue developing our game.